Hi everyone, this is Mrs. Snowbeck. Today we are doing Unit 3, Lesson 5, called Two-Column Proofs. If you talk to your parents about, hey, what do you remember from geometry when you were in high school? I bet almost all of them will say that they remember doing proofs and that they were rather difficult and kind of tricky. So that's what we're going to work on today. We're going to learn how to do something called a two-column proof. Before we start doing the proofs, you're going to need to have some background on a few theorems and postulates. So some things that people have proven true or that we just know are true. The first one's called the reflexive property. And the reflexive property of congruence just says that everything is congruent to itself. You are congruent to you. Or, like in this picture, triangle ABC is congruent to triangle ABC. It's the same size as itself. That's called the reflexive property. Next, we have the symmetric property. And the symmetric property says if triangle ABC is congruent to triangle DEF, then triangle DEF has to be congruent to triangle ABC. So imagine that we have two triangles. So we have this one right here, triangle ABC, and it is congruent to triangle DEF. Well, then does it go the other way around? Absolutely. Or if Joe's the same height as Nick, is Nick the same height as Joe? Yes, it has to be true. So it goes both ways. That's called the symmetric property of congruence. The third property that we're going to talk about is called the transitive property. And the transitive property basically has a middleman. So it says if triangle ABC is congruent to triangle DEF. So imagine this first triangle is congruent to the middle triangle. But the middle triangle, DEF, is congruent to triangle GHI. So that's congruent. Then does ABC have to be congruent to GHI? The answer is yes. If they're both congruent to the middle triangle, they have to be congruent to each other. And that's called the transitive property, when there's like a middleman. Another thing that you'll need for proofs today are the triangle congruence theorems that we learned in the last unit. So remember, these are used when you are trying to prove that two triangles are congruent. So if you have three sides in one and they're congruent to three sides in another, then the triangles have to be congruent and so on. So you're going to need these side, 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 angle, side, angle, side, angle, and angle, angle, side congruence theorems. Remember, no swearing in math. This next one is really important. It says corresponding parts of congruent triangles are congruent. So basically what this one says is once you know that two triangles are congruent to each other, the same size, then all their matching parts have to be congruent to each other. All matching angles, all corresponding sides, they all have to be congruent. And you're going to want to memorize this. CPCTC. Corresponding parts of congruent triangles are congruent. Finally, you might have to use some of these things in your proofs as well. The first one, definition of midpoint. Remember, if you have a segment and you know that you have its midpoint, the two parts, the two smaller parts, are going to be congruent to each other. This would be the midpoint, right? So the midpoint means it cuts that segment in equal halves. Next one, vertical angle theorem. Remember, the vertical angle theorem just says that angles across from each other are the same size. Definition of a linear pair. Remember, the definition of a linear pair is you're going to have two adjacent angles that are supplementary. And just, to remember, they add up to 180. Definition of a segment bisector. So if you have a segment and it gets bisected, it gets cut in half, kind of like a midpoint. That line might go through the midpoint. If you have an angle bisector, so if you have an angle and then you bisect it, that means you cut it in half. So you have a ray sometimes, that's an angle bisector. And definition of a right angle, you might have to use that. If you know something is a right angle, you know it is 90 degrees. And then you might have to use things like alternate interior angles, alternate exterior angles, consecutive interior angles, corresponding angles. Because remember, if the lines are parallel, then those types of angles will either be congruent or supplementary. So here we go. We're going to do our first proof. It's kind of like being a lawyer in the courtroom. You're going to get some information and you're going to try to prove that something's true, and you have to prove it in a logical order. And so we're going to list our order of events, so to speak, in two columns. The first column is called the statements. The second column is called the reasons. So you're going to make a statement and then you're going to tell the reason why you know it's true. Now, let's look at the given information up at the top here. It says segment NQ is congruent to segment PQ. So you can see this segment is congruent to this segment. Well, that's great, but let's keep reading. Next, we have segment NY is congruent to segment PY. So this segment is congruent to this segment. And we want to try to prove that the two triangles are congruent. This is what we're trying to prove based off of the information we have. So here's what I'm going to do. Every single time I start a proof, I'm going to start with number one, the information that I'm given. So I know for a fact NQ, segment NQ, is congruent to segment PQ. I know that for a fact. I also know for a fact segment NY is congruent to segment PY. I'm going to put them both in number one. Why do I know they're true? Because it was given information. Whenever you do a proof, you're going to start with your given information. You're going to put the statements in number one, and you're going to have its reason as given. That was given to you. Now think about what you're trying to prove. You're trying to prove that the two triangles are congruent. So I'm thinking, in order to prove the top triangle is congruent to the bottom triangle, maybe we could use something like side, side, side. And I'm thinking of this side in the middle. And even though they don't say it, it's the same size in both triangles, right? So number two is segment YQ is congruent to, I should say segment YQ in the top triangle is congruent to segment YQ in the bottom triangle. Why do I know that? Because everything is congruent to itself. That's known as the reflexive property of congruence. So I'm just going to write the reflexive property. Again, that means everything is congruent to itself. So I now know that I have three sides in one triangle that match up with three sides in another triangle. So I think I can prove it. Whatever you're trying to prove goes in your last statement. So I'm going to copy down triangle NYQ must be congruent to triangle PYQ. Notice I copied it exactly how it looks up here. And the reason I know that that's true is because now I have shown I have three sides, side, 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 that are congruent to the corresponding sides in the other triangle. And we're done. We have just done our first two-column proof, and we've proven that the triangles must be congruent to each other. All right, number two. So we're going to start by making our two columns. Remember, it's statements and reasons. So I go statements, reasons. Number one, always start with the given information. So copy down exactly the information you're given. So segment RQ is parallel to segment TS. Segment RQ is congruent to segment TS. The reason I know for a fact that that is true is because it was given to me. Now, I like to kind of think about the information they gave me. RQ and RS. Here's RQ, here's RS. They're telling me that those two segments are parallel to each other and that they're congruent to each other. Okay, and then I want to look at what I'm trying to prove. I'm trying to prove that triangle RQT, so that's the triangle on the left, is congruent to triangle TSR, the triangle on the right. I think in order to prove that these two triangles are congruent, I need one of those shortcuts. I need like something like side, 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 or side, angle, side, or angle, side, angle, or angle, angle, side. I think I want to try to get one of those. Right now, I only have one thing. I have that side RQ is congruent to side TS. So I need some more stuff. And one thing that stands out to me is side RT. Because side RT is in both triangles and it has to be the same size in both triangles. So number 2, I'm going to say, oh, segment RT in the left triangle is congruent to segment RT in the right triangle. And the reason is everything's congruent to itself. The reflexive property of congruence. You're going to use that one a lot. Cool. Is that enough information? Nope. I only have 2 sides so far, and I need at least 3 things. I do not think I know anything about the third set of sides yet, anyway. However, the fact that these 2 blue lines are parallel to each other makes me think about, like if this is parallel to this, and then segment RT cuts through like the transversal, I'm thinking of this angle right here, angle QRT, and angle STR, those 2 green angles, right? Right in here and right in here. Those 2 green angles, they're between parallel lines. They're cut by a transversal. Haha, I think those 2 angles have to be congruent. And their reason is, I think they're alternate interior angles. And if the lines are parallel, they're congruent. So I'm going to say angle QRT has to be congruent to angle STR. And order matters. You want to list them in corresponding order. And the reason I know that they are congruent to each other is because they are alternate interior angles and the lines are parallel. But if you just want to write alternate interior angles, that's good enough for me. Now, do we have enough to prove that the 2 triangles are congruent? I'm thinking about the 2 triangles, and I notice in the triangle on the left, I have a side, an angle, and a side marked. Let me show you that. Think about side RQ, it has a tick mark, the angle up here, and then the side over here, side, angle, side, single, angle, double. Now go to the other triangle, we have single, angle, double. Haha. So I do think we now have enough. So step number 4 is what we're trying to prove. So remember, your last statement is always whatever you're trying to prove. So triangle RQT is congruent to triangle TSR. And the reason is I have a side, an angle, and a side that correspond with each other in the 2 triangles. Number 3, please make your 2 columns. And once you have your 2 columns made, go ahead and do statement and reason number 1. Remember, every single proof you're going to start with the given information. So I just copied it exactly down as it was written at the top of the screen. Now I'm going to go back and look at the information and kind of try to figure out what it's saying. Angle ATR, that's this angle over here. If I trace from A to T to R, is congruent to angle STR. So S to T to R, that's going to be congruent to this angle over here. So those 2 angles are congruent, and that was given to me. Also, AT, so this side, is congruent to ST, this side. That was given to me. And the thing that we're trying to prove is that angle S is congruent to angle A. Well, here's what I'm thinking. I'm thinking that maybe first I need to prove the triangles are congruent. Because then, once I know the triangles are congruent, then all their corresponding parts also have to be congruent, which means angle S would have to be congruent to angle A. So the second thing I'm going to put down is something that will help me prove the triangles are congruent. It's side RT. So I'm going to say side RT in the top triangle is congruent to side RT in the bottom triangle because everything's congruent to itself. That's the reflexive property of congruence. Now look at what we have on the triangles. In the top triangle, we have a side, an angle, and a side. And in the bottom triangle, we have a side, an angle, and a side. So now I can say, oh, well, that top triangle, triangle rat, has to be congruent to the bottom triangle, which I think is RST, if we put that in corresponding order. And the reason I know that they're congruent is because I have a side, an angle, and a side. And finally, step number 4 is now I can prove that angle S is congruent to angle A. So whatever you're trying to prove will be your last step. Angle S is congruent to angle A. And the reason I know that is because I know the triangles are congruent. And corresponding parts of congruent triangles are congruent. CPCTC. Corresponding parts of congruent triangles are congruent. So a couple last comments about proofs. There are other types of proofs that you can do. You can do a flowchart proof, you can do a paragraph proof, but we are going to stick to just 2-column proofs. So anytime in your homework or anything coming up, if it says write a proof, it means write a 2-column proof, just like these, where you list out your statements and your reasons. Second thing I want to say about it is proofs can have any number of steps. The shortest ones that I've ever seen are 2 steps. The given information gives you enough that you can prove it right away. Sometimes I see that. You're not going to have any with only 2 steps. I've also seen proofs with 30 steps. So you can have, any number of steps. It's just going to be however much it takes you to prove it. At this point, I want you to try Unit 3, Practice 5. It's going to be a bunch of 2-column proofs. Because this is such a new skill and you haven't done it before, I'm going to make a second video that goes through a few of those homework problems. So try them first on your own, but if you find yourself struggling, I am going to post a second video that will go through some of the Unit 3 Practice 5 homework problems. So watch for that if you need a little help. You can also Schoology message me. Have a great day.